Hey, good morning, everybody. How you doing today? Happy Monday. Hope you're doing well. All right, we got a couple things on tap today. Let's see. There we go. We got our schedule. All right, so today we're going to talk about inheritance. We're not going to go super deep on inheritance, but we need to cover the basics of it. Yeah, this is one of the fundamentals of object-oriented programming, which is really cool. If you continue on into 2151, we'll do a whole lot more with inheritance as well. But we need to talk about this before any of this GUI application stuff is really going to make any sense, because we take advantage of inheritance when we create GUI applications. So we need to cover the basics here, so we get a nice foundation there. And then don't forget your arrays and array list project, our big int, which also is based on classes. So classes and array lists is coming up due. Can't encourage you enough to go to study group and to get working on that. Get to know your classmates and work with our awesome SI to get a head start on that, because that one is coming up due. Let me double check the date. I should have looked at that first. Before you know it. There we go. Yep, April 5th. So that is a week from today. Yep, a week from today. We'll cover that one. So definitely get started if you haven't yet. You want to kind of puzzle out some of those steps and how this needs to happen. Talk about pseudocode. Yeah, April 5th. Thanks, Demovsky. Demovsky. There's a V in there. I'm sorry. I got to remember that. So you'll want that. Let me fire up NetBeans here. And we can start looking at inheritance, which is really cool. Oh, yes, a rubric for the project. Thank you. Yeah, that one in here. Good question. Thank you. Good morning, Fallen. Hope you folks have your coffee. I just started another pot, so I've got this one, and then my other pot's brewing, which is nice. I'll be ready for me when I take a break. I'm excited. Oh, can you folks do me a favor? If you haven't yet, man, I can't spell. My YouTube channel over there, I just got a link in the chat. I need like 6 more subscribers until I can get a URL that doesn't look like gibberish, right? And I can put my name in it, like my Twitch link. So if you haven't subscribed yet, would you do me a favor and just subscribe? You can unsubscribe later or when the semester's done. It's okay. But, oops, I need all of that. They don't... I feel like you should be able to make the rubric while you see the description of the project, but maybe that's not the case. What is going on? Where's my copy? Is it gonna be one of those days again? Copy. Hey, there's no paste. There's no paste. There's no paste. Okay, that's all right. This button, that button, too many clicks. Goodness. Okay. So we have add, we have subtract, we have string, unit tests, big int. Okay, or array. I don't recommend anyone use the integer array, just FYI. Using the array list of type integer is going to be way easier for you. Okay, remember one of the big differences is once you make an integer array, you can't make it bigger or smaller. With an array list, you can. So you don't need to know how big this needs to be to start with an array list. You can just keep adding digits, right? With the integer array, you can't do that. You could make a new one and copy it. So it's probably not the worst thing in the world, but it'd be a little bit obnoxious. Okay. All right, and this one here, the whiteboard. Couple cool things with the array list I want to show you. Oh, thanks so much. Appreciate it. This is 1500. This is inheritance. Inheritance. It's probably spelled wrong. That's okay. Excuse me. All right, so let's go to this rubric thingy. This is project 4. Project 4. Take out some of these middle ones here. I think this rubric style is meant for like the English papers, that sort of thing. We just have either you did it or you didn't do it. Make it a little easier. So you have a private int array or array list of type integer. Store the digits. There's 5 points there, just for writing the class. Okay? The big int add method accepts another big int to add and creates a new big int result. Remember, all of these here, you don't modify the originals. You're making a new result here with unit tests. It's 5 points there. Big int subtract, and 5 more points. Big int. Oh, goodness. There we go. String method. It's out a nicely formatted value with thousands separator and negative indicator. Separator. Did I spell that wrong? Separator? I thought it. Formatted. Oh man. There we go. Okay. This is the subtract method, except another big int to subtract. Nope, that was the add one. This one's the subtract one. Subtract. Okay. So I'm not explicitly asking for unit tests on this one because you're probably using the unit tests here when you're doing your add and subtract. That's going to be your easiest way to say, hey, here's the string I expect to get back out after I add these things together. Right? So any remaining unit tests needed for 100% code coverage. With unit tests. Okay. And this big int class, you'll need a constructor to create them. So any way you want to make your constructor, I'm okay with. I recommend you probably accept a string. It's probably the easiest bet. If you can take a string, right, it'll be easiest to make those. Because if you have to turn everything into an array list to hand it the digits originally, you know, you could. So that's okay too. And then you also need to tell it positive or negative. I mean, positive is probably the default, so you have to look for negative. Same with the string, you just look for the negative sign, that sort of thing. Okay. Ooh, we were talking about hex. There we go. That was fun. All right. So remember with our big ints, right? So we had, if this was an array list of integers here, so like 3, 7, 4, 9, 2, 8, 1, 5, 7. I'm just going to add in these to remember that I have digit groupings. 2, 3, 9. Okay, so it's bigger than an integer in Java, right? Because we can't get to more than 2 some odd billion with an integer in Java. And you can use long, but again, we're going to be even bigger than, so we could be as large as we need to be, right? There's almost no limit to the number of integers we can throw into an array. There is some theoretical limit, but we're not going to get there, so don't worry too much about it, right? Now remember, with our index notation, we're dealing with arrays. So imagine this is an array or array list. Again, you can get at stuff by index, right? This here is index 0. This one is length -1. Remember that? We go from 0 to length -1 for our indexes. Okay? Just keep that in mind when we're dealing with our values here to see which one. Okay? Now, if we were to take this and we were to add another array list to it, or another big integer to it, right? So throw out some numbers, I'll add them to another big int, and then we'll see if we can do some arithmetic with it. Okay, 96. All right, so we'll do 96. Anyone else have any digits they want to add? $54. Okay. Thanks, CyberPixie. Thanks, Dusty Nuts. Okay, 23, 42, 4, 2. Right, making sure I'm lined up here. Okay, so there's our separators. Okay, I'm a little out of line here. Well, this will work. Is Mayo a number? No. Okay. So remember what we're going to do here. If we wanted to add these together, let's do the add operation first. So this one here is index 0, and this one is, we'll just count them all. So 0, 1, 2, 3, 4, 5, 6, 7. That's our indexes here, right? And then to get these other indexes, let's go count all those as well. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So which index do we need to look at in the first big int, and which index do we need to look at in the second big int to add the ones place together? Right, because the first thing we do is we add the ones place, right? Think back to second grade math, right? When you start learning to add 2-digit numbers, 3-digit numbers together. Is that second grade math? I think so. Right, we're looking at index. Here we need to start at length -1 for both of them. Okay, that's a different value for each of them, so I can't use the same loop here because they don't have the same index. There's no guarantee. Yeah, my favorite Pokemon. Snorlax today. Man, I used to play Pokemon Go when I was on campus. Actually, I haven't played at the Orchard Ridge campus. I'm incorrect. At U of M Dearborn, I played Pokemon Go a lot. Because where my office was, there were 3 different Pokestops I could spin just from sitting there. So I could just leave my phone up. And there was actually a pretty good a group on campus that would do raids. So I was able to get a lot of the raids done. That was a lot of fun. I miss being around people. As much as I love computers and, you know, that sort of thing, I miss people. I'm excited to get back to normal. Today, I'm driving down to Ford Field. I had to go get my second shot. Super excited for that. And hoping it doesn't put me out for a day and a half like the first one did. So, all right. So again, we're going to find the ones place here, which is the largest index, and we're going to work our way backwards towards 0. Right? So we're going to start large and go down to small. Okay? So there's a lot of logic that has to happen here, but we're just going to break it down step by step by step by step. So 7 plus 6, right, is 13. So we take the ones place of that, and then we need a carry. We add a carry. Then we look at the next index here. Okay, we get 9 plus 5 plus a carry. We get 15 with another carry. Right, then we look at the next digit, the next place here. So this is 4 plus 1 plus 1, so we get 6. There's no carry here. Then we get 8 plus 5 is 13. There's a carry. We get 2 plus 3. Pardon my drawing, I'm a little crooked here. We get 6 with our carry. There's no carry. Then we get 9 plus 2. Right? And that is 11, so there is a carry here. We get 4 plus 4 plus our carry is 9. 2 plus 7, no carry, is also a 9. uh-oh, now what happens here though? There is no value left, right? After index 0, I've got nothing left to add. If I try and access index -1 or -1, it's going to crash, right? You get that invalid index error. So we need to stop looking if it's no longer, if it's less than 0, right? And then I just get my carries, or because there might be a carry, there might not be. So then 3, 2, 3, 9. We have to put all these digits into a new array list and hand it to our big integer, right? Kind of what happens behind the scenes, right? A big int. If we make a new big int here, right? Big int has that private array list, right? Of type integer. Oh, sorry, some of that was behind my face earlier. I always forget I've got a face in the bottom corner. I'm looking at my screen. So we need to add those digits to it or call the constructor. Either way you want to go about it, right? Either way is okay. So we could turn this all, we could leave this all as an array list and then hand an array list to a constructor. We could add all this to a string and add a string to a constructor, or we can just create a big int with nothing and then start adding the digits to it. Either way is perfectly fine. Remember, if you want to, when we're using array lists here, let's go play with an array list real fast. So if I have an array list of type integer, you know, maybe we call it digits, right? Because it's the digits. Digits, I think that's spelled right, equals a new array list. And yes, that means please import. Oh yes, and I test project it. That was fun. That was fun. I've got big plans for things coming up. I'm super excited. There's some really cool tools we can use. So I'll be piloting them over the summer. Which summer registration is still available, by the way. Go register for summer classes. Line. Let's see if they're full yet. Oh, I got to save the rubric, right? So 5 points for the class and the constructor, 5 points for add, 5 points for subtract, and 5 points for toString. I think I got everything in the... Oh, it's 25 points total. My goodness. Did I do that wrong? I did it wrong. I need 5 more points. With a Boolean for positive and negative as well. Okay, let's go edit that rubric then. Okay. Hang on, I got to go back to the rubric. Goodness. I forgot how to add rubrics. This is why I double check myself, because stuff like this happens all the time to me. Neck is super itchy right here. I got my little guy scratched me. All right, this one I don't need. That was the extra one we created. Project 4 we need to edit that one. Come on, D2L, wake up. Get it. There. Let's see, okay. Let's see if we can log in while that loads. Let's take a peek at summer classes here. We're going to search for all CIS courses over the summer. See what it looks like. And there are summer scholarships. I posted in the Discord. There's that Universal Scholarship application. We at least for sure have the summer momentum scholarship. So depending on whether or not you're full-time or part-time, if you've been here for fall and winter, you can qualify for some free money if you're going to continue taking classes over the summer, which is super cool. I was really excited to see that. Yep. So if you might move into 2151, I'll be doing that one Tuesday nights. C++ with Dr. Baugh. It's fantastic. You got lots of open seats there still. But 2151, yeah, 16 seats still open. That's good. You got lots of room. Data structures as well. Someone had reached out and asked, the only prereq for data structures is 1500. And that's true. You can do the class after taking 1500. I usually recommend people take 2151 before doing data structures, just so you've had another semester worth of programming in Java to get more familiar. It's not required, so if it fits your schedule, great. If it doesn't, you can do it, but it'll be a little tough, right? So I'm also teaching that one Wednesday nights, or the web development course 2454. I'll be doing that one Thursday nights. Or if you want to repeat 1500, right? If it didn't go so well for you, I'll be back Monday nights, or you could take it with someone else who's doing 1500. McAllister's really nice. I don't know who's doing this one. So you got some other options here if you want to take it with somebody else. Ooh, that's an 8-week course? Holy cow. That's going to be rough. Monday, Wednesday, 8 hours a week of Java 1 to get this thing done in 8 weeks. Whew. It's doable. It's definitely doable, but that's kind of a rough schedule. Anyway, our rubric here. All right, what did I get wrong here? That's right, I need 5 more points. My list store the digits, need to construct to create them, and a Boolean to indicate positive or negative. Indicate, there we go. So that's 20. I didn't add up right. Okay, let's do this. Let's do this. I'm gonna separate out the unit tests here. Unit tests. 100% code coverage. I'll make that its own category here, and it'll just include unit tests for everything here. Okay? And that'll be separate. So I want that one to be worth more though. So let me do this. I'm going to custom points. Like that. That's 4, 4, 4. 4 is 16 points there. That leaves 9. 9 points for unit tests. Should be 25. Okay, so that's 3 points for add. 3 points for subtract. And 3 points for to string. Okay, does that make sense? I could break them down into separate ones. Sorry, but I don't know. Is this okay? Or do you want separate categories? It just means more clicking if you want 3 different ones. I think you guys get it from here. This is your overall score. Again, that category is silly. Okay. Cool. So now we have 25 points on that rubric for the 25-point assignment. Questions, thoughts, concerns? Again, due Monday, next Monday, 10 a.m. I'll go over the solution to it. I can probably guarantee this is going to be harder than it looks. Right? Kind of talking through it step by step by step by step here is not so bad. Actually doing it in code is a little bit trickier. Right? There's a lot of little details you have to figure out here. Okay. As another example, right? If we were to kind of flip this around here, let's copy some of these numbers here. I want to zoom out a little bit. I'm going to copy these numbers to another one. Let's do 2, 4, 2, 3, 5, 4, 9, 6. And let's say we were going to maybe subtract this big number from it. 9, 3, 2, 3, 7, 4, 9, 2, 8, 1, 5, 7. Oh, those didn't line up at all. Oops. Okay. That's okay. We're going to have to rewrite it anyway. Okay, so if that's our problem, right, and we need to subtract one from the other. Remember what we need to do first. We need to actually flip it to see which number is bigger. Because we need to always have the bigger number first before we subtract. Because we don't have a way to really do this the other way. Right? Like if you take, let's just go over here. If you take like 23 minus 47, we don't, like you can't do 3 minus 7. I mean, I guess you can, but it's going to be really funky, right? Because then it's just going to be weird, okay? So we're not going to do that. So we're going to say, oh, well, that's really the same thing as 47 minus 23, okay? And then the whole answer becomes negative, right? That we can do. We can do 4 and 2. It's negative 24 is our answer, right? So we need to find which is bigger and flip it, okay? So we need to change the operation here. So sure, so it's going to be 9... Oh my goodness. 3, 2, I can't. That's okay. 9, 3, 2, 3, 7, 4, 9, 2, 8, 1, 5, 7, minus, and let me write this the other direction here, 6, 9, 4, 5, 3, 2, 4, 2, that direction. And then the whole thing will be negative, right? The answer of this then will be, we know will be a negative result when we're done. Now we can do subtraction, and subtraction requires borrowing, but we know there's always going to be something to borrow because we have a larger number on top. Okay, otherwise, like, you run into this and you're like, well, how do I borrow from this? Like, okay, sure, we could do 23 minus 47. We could say, sure, you can't take 7 away from 3, so let's borrow here and do 13. 13 minus 7 gives you 6, and then you're like 1 minus 4. There's nothing here to borrow from. Is that negative 3? But it's not negative 36. Like, so like you can't do that. Okay. So you've got to do this flipping thing here. That's our operation here. And then we can do our subtraction, right? So 7 minus 6. Again, start at the largest index, and you work your way back down. Right? Largest index, work your way back down. So 7 minus 6, sure, we can do. 5 minus 9, we can't do. We need to go borrow. So you need to go to your neighbor, right? Borrow 1 from the neighbor. Now we're 15. 15 minus 9 we can do is 6. 0 minus 4 we can't do. We have to go borrow. So 7 and 10 is 6. 7 and 5 is 2. 2 and 3 we can't do. We have to go borrow. 8 and 12. We get a 9. 8 and 2 is 6. 4 and 4 is 0. 7 and 2 is 5. And then there's nothing left, so then the rest of the numbers just drop down. And then the whole result becomes negative. Okay? So remember, there's a bit of it here. So if you have to do borrowing, you need to make sure we're changing the neighbor's number. But the problem is, you can't change the original here. If you actually go to this original number and you change it, right, where you say, oh, let's actually change this digit from a 9 to an 8, what's going to happen if I want to use that original number again? Remember, math doesn't change this. This number doesn't change, and this number doesn't change. When I do 47 minus 23, 47 is still 47. 23 is still 23. Right? We can't change those values during our arithmetic. So when you print something back out, after you've done your arithmetic, it should still be the same number. Right? So like if this is big int 1 and this is big int 2, right? Big int 1, int 1, and this is big int 2, those don't get to change. Right? We make a new big int 3, or whatever it is, and we return this result, big int here. Right? We're going to return a new result, and we don't change the originals. Okay, so we can't change it in the original when we're doing it. So we need a way to know that we need to be doing this without changing it. Okay, there's a couple methods for that. Right, a couple different ways of going about that. Either way is okay. All right. How do we feel so far about this? We got a week left. Curious here. Let me run a poll just for fun. This says, because I'm curious here. 4. So just two answers there. Either you've started it or you haven't started it yet. Just let me know in Twitch chat. There's a poll feature there. Curious. I tried really hard last week to get you folks to go to the SI sessions and start the project, and I'm not sure it happened. But now we have a week left, and I'm hoping that with a week left you'll realize this is a lot of work and we need to get started on it. So if you haven't started yet, hang out after class, right? Our SI session today, noon to 1, and Wednesday, noon to 1. And it will even give you a bonus point on your quiz, which is awesome. Did I post? I think I posted the quiz for you folks, right? I posted that quiz? Let me look while we do that Twitch poll. Let's see. Let's see. The Chapter 6 quiz. Yep, okay, due March 26th. Did not get as many people to take that one. I can take this late. Right, please still get it done, the Chapter 6 quiz. But I didn't do one on Chapter 7, did I? So I need to post a Chapter 7 quiz on your array lists. Let me leave myself a note. Chapter 7 quiz, array list. You know, I had a note, and I think I didn't end up doing it because I forgot. These notes aren't perfect. All right, so we get 1 person started, 3 people haven't started. Thank you for your honesty. Definitely stay after and go to study group, noon to 1, and talk about it here. Right? You are welcome to chat about ideas, how you track these sort of things. Pseudocode's perfectly fine to talk about. Right? This idea, here's my steps in English. Let me break down the problem, do some functional decomposition. Right? What does it look like to add? What does it look like to subtract? What does it look like to turn it into a string? Those sort of, what are my steps going to be here? And that's great. Just if you start talking specifically about code and sharing code, we've gone too far. Okay? Cool. Cool, cool, cool. You feel all right? Close that down. We'll come back here. Oh, I wanted to show you again with digits, right? Digits, that's a D. Right, we get a couple methods here with digits. Digits dot y digits dot. Oh goodness. I made NetBeans upset with me here. Digits dot. Was I spelling it wrong? Maybe I was. All right, it's loading. It's loading here. Remember, we can add to it, or we can add to it at a specific index. So depending on which way you want to do this, right, we can add to the end, or we can add to the front. Oh man, come on, add. There we go. So add can either be, here's the number to add, or add a number at an index. So if I add a digit here, oh, I closed my whiteboard. That's okay. I'll open whiteboard again. Right? If you take an empty array list, oh, computer is not happy this morning. It knows it's a Monday. So if we take an empty array list here, so if we have that's an array list, not a big int. Right? It's empty currently. Adding, we'll just put a number there, like 5. Then I can either add to this side with add, or I can add to this side with add at index 0. So add at index 0 will add to the left, add just the value will add to the right. So depending on how you want to build these things, if you want to build them starting at the ones place, right? If you just keep adding to 0, the ones place will stay, right? So I can start with a 1, or add a 1, add a 6, add a 6, add a 2, add a 9, add a 6, add a 0, add a 5, add a 3, add a 2, add a 3, add a 9. You can build it from ones place on with this add 0. So if you add at index 0, it becomes the new leftmost value. That's one approach, right? Either way is okay. Or we can turn it into a string, right? Or we can just make an array list and then don't mess with it, or make the array list and do mess with it. Right? Totally up to you. Any way you want to be creating these big ints, right? Up to you. So just that add method is really cool. Okay. All right. I won't have office hours today because I got to go drive down to Detroit to get that shot at Ford Field. That's super cool. They've got that opened up there. But I'll be on later in the afternoon if anyone wants to chat today. I have office hours Tuesday and Wednesday from 1 to 3. Just real briefly on Thursday, 5:30 to 6 between all the crazy classes I have on Thursdays. And that's my availability. So please don't plan on trying to meet with me Friday or over the weekend if we can help it. Let's get this stuff done earlier, and it'll make everybody happier. Okay? Like if you're stuck down to the wire, I'll do my best to try and chat with you over the weekend. I'm usually around on Discord, but I've got plans this coming weekend, so it's a kind of a busy weekend for some people. So let's please plan accordingly. All right. We're ready to start inheritance, or should we break now? No, it's kind of early for break. I haven't been talking for that long, and I still have coffee in my cup, so we got a little bit of time. Oh man, this weather is driving me crazy. I finally got my hair cut. I was very excited. This is my usual summer cut here. It's getting too long. All right. So we've talked about classes, right, where we can add a class to do things here. Let's go make a class here. So I'm going to add in my package. I'm going to add a new class, Java class, and let's call this one. Let's do Polygon. This is always a fun example. Right. And polygons, if you remember back to geometry, have a number of sides, right? And then they have length of sides. I'm going to make an integer array list of type integer, side lengths. Okay, those are things we know about Polygon. And maybe we'll give it a name as well, private string for name. So you can name your polygon, you can have a number of sides, and you can have an array list of integers. And those are all the attributes. Those are things that make this instance of Polygon unique. Right? I can have all sorts of different polygons here. This is just the blueprint for creating them. That's what my class is here. Okay? So I'm going to write a constructor for Polygon. So a constructor has the same name and no return type. So Polygon. And what do I want in the constructor? Well, I want a string for the name, and I want an int for the number of sides. Okay, so I'll set my name to the name provided, and I'll set my number of sides to the number of sides provided. Then the other thing I have to do is I need to give a value to my variable here. The constructor's job is to set values for all of your attributes, right? Default values or values that are provided by the argument. Either way is okay. So I'm going to say side length is a new array list of type integer. Okay, and I can even size it here. This is not necessary, but it'll make your array list be slightly more efficient. If you tell array list how big it's going to be, it can work a little faster if it's dealing with really large numbers. Again, for our purposes, probably not a big deal, but this is one of those optimization things that you don't need to worry too much about for now. But it's a good habit. Right? If we know how big it's going to be, let's just make it that big to start. Okay, and then what we need to do is we need a way to set a side length. So I'm going to make a void method here. We're not going to return anything. We're going to call it set side length. It needs an int for side index and an int for side length. Right, you tell me which index and how long it is. Okay. Then what I can do is I can take my side lengths and I can call set. Remember, set will change the value, and I want to set the side index to the side length. Okay. And then other things Polygon can do, right? We can get a side length. That is, we'll return an integer. Get side length, right? All these get methods are giving a value back. So this, I need a side index. You need to tell me which one you want. Here, so I'm going to return side lengths of .get the index, side index. I need a way to give back the name, so a string for get name returns the name, and a public int get number of sides returns the number of sides. Okay, so format. Right, all the get methods just give public access to, these are what my variables are. Now, I don't have a get side lengths, all of them here. You can get one at a time. Right, so get a single length. If you return an array list, right, we talked about when you pass objects, you're passing the reference to them. They would have direct access to go modify this thing, and that might be bad. Okay, because maybe we want to do something smart here and check. Like before we set our side lengths, we want to check, hey, if the side length is greater than 0, let's go do this operation. Right? If it's not greater than 0, let's just not do it. Right? Because we want to make sure we're like actual objects. I think in math class you can have objects of the negative length, but I don't understand how that works and it hurts my head. So I'm going to say you can't. Right, for ours. So set side lengths is going to protect the integrity of our class. Remember, with our fundamentals of object-oriented programming, we're encapsulating all of our details together into a class. We're taking all the things about it, all the attributes, encapsulating them together, exposing public methods so you can interact with it abstractly. You don't need to know the details when you call these methods. You just know my class is going to do the work for you. Right? Just like with scanner. We don't know how scanner works. Right? We just know it will go and read the next line for me. Great, we love it. We don't need the details. So we're interacting with it abstractly. Okay? What is it not like? The diamond operator. Sure, that's fine. Remember, if you've declared a type, you don't have to tell it the type again if you want to save some typing. NetBeans is all about saving some typing. Right? NetBeans is fantastic. It teaches you good habits. So, okay, so we've got all the details we need here. Again, we're protecting the integrity of our class. We've encapsulated all of our details, and we're going to make sure no one puts me into a bad state. Right? The class's job is to protect itself and make sure it doesn't go into a bad state. So we might also want to check then with number of sides to make sure it's greater than 0. We have a positive number of sides. Right? So if number of sides is greater than 0, we'll do these operations here. Otherwise, right, if it's not greater than 0, else, well, let's, I guess, set them to 0. 0 is ugly, but that's fine, I guess. Sure, why not? Okay, give it a little format. Cool. So now we'll come back to inheritance, and let's make a polygon. So polygon, how about we make an octagon? Octagon equals a new polygon. Polygon. And polygon needs a couple things, right? It needs a name. We'll call it an octagon. That's our name. It needs the number of sides, 8 sides. Okay? And then we want to go through and we want to set the side length. So again, we could do it one at a time, or I could use a loop, right? So for int index is 0, index is less than 8, index plus plus. Oops, there's a semicolon there. Let's loop through and call octagon dot set side length of index to, let's say these are all, I don't know, 5, whatever, 5 length, okay? We can do that. Oh, we forgot one other thing Polygon can do, right, is get a perimeter. Int get perimeter. Perimeter? That sounds right. Right, Polygon can calculate its perimeter. So we have an int for perimeter. Starts off at 0, and then we're going to loop through. So for int side length, in side lengths, take my perimeter, plus equals the side length. I add to it. When we've looped through all of them, when we're done, return perimeter. Again, this is that enhanced for loop. It's not using index notation. It's just using the for item in collection notation here. Either way is okay. If you want to use the other loop, that's fine too. All right, the other one would look like for int index is 0, index is less than side lengths dot length or dot size. No, yeah, dot size. So size for array lists, length for arrays, index plus plus, perimeter plus equals side lengths dot get the index. Right? Either one of those is fine, right? This one, right, when you're looping this direction, you can modify the value. When you're using this enhanced for loop, it's essentially a read-only loop. You got to be careful here. We can't be changing the values inside of it here. Sorry, my watch is dying here. I got to plug it in. The fun thing with watches, right? Oh, come on. Where's that cord? I got too many cords on my desk here. There it is. Come on. All right. There. Ooh, it's only at 9%. Goodness. Okay. So again, either loop's okay. I'll leave this one commented out for now. As Control/ for commenting or uncommenting. So same as above, or essentially the same as the above. Essentially. Right. So again, we could modify it here if we're using the set notation if we wanted, and here we can't change the values. And we'll give back a perimeter. Okay. So, and then if we wanted to have a toString method for this, right? Let's go to Polygon. Let's do that. Let's add a public string toString method here. And this is actually, we're going to add this override notation, which is super cool. And this is what we're going to talk about inheritance today. So inheritance is saying, give me a better version of toString than what I would get before. Actually, we'll leave it commented. We're going to come right back to that. So if I wanted to print out my polygon, I could print out octagon. And what I get is the object version of toString, which is the name of the class and its memory location. Essentially garbage. Give it a run. It's not going to run, is it? Okay. Yeah, let me check my project properties. Ooh, I realized I don't think I have this NB JavaC plugin, and I think that's why this doesn't work. Uh-oh. Did it crash on me? It did run. It crashed on me, though. It did. Uh-oh, an index out of bounds exception. Index 0 out of bounds. Remember, you got to read them kind of from the bottom up. Inheritance, line 11. Here, called Polygon at line 24. Setting the side length. Uh-oh. When you create an array list, just because you tell it how big it's going to be, doesn't mean it gets a bunch of values. All right, so what we need to do then, we need to go through and we need to say for int side is 0, side is less than number of sides, side plus plus, let's go through and take our array list, side lengths, and let's add a 0. Right? Until you tell me otherwise, I'm going to assume the length is 0. So I'll make it, and then I'll add zeros for all of those side lengths. Then I can actually go set those side lengths over here at an index, because I'll have that index. Right? Just because I told it it's going to hold 8 doesn't mean it size it. So with an array, when you tell it size 8, you've got 8 zeros right off the bat. With an array list, you don't. All right, now let's give it a run. All right, and what we get when we print string, right? Name of the class, Polygon at memory location. We get garbage. So what we want to do, and the reason we have this, right? When we go back to inheritance here and we look at octagon dot, you'll notice we get a bunch of these cool methods here. Oops, octagon dot. Some of them are bold, like get name, number, size, perimeter. Some of them are not bold, like hash code, notify, toString. So, and if you click on them, it says, hey, this is from java.lang.object. Java.lang.object. This one here, the bold one, is inheritance.polygon. So the ones in bold come from the Polygon class. The ones that are not come from the class object. So technically, behind the scenes in Java, anytime you ever write a class, it will inherit from object. That means it is an object. Right? Inheritance creates this is a relationship here. So all of these things are objects. An object has some built-in code for us to do some certain things. Not all of them are helpful, but, you know, toString, it'll at least let us try it. It won't crash, but we get a garbage result. So what we're going to do through inheritance, we're going to say, hey, I know I have this version here from object. I want to override it. I want to give a specialized behavior. So what we got to do with inheritance is we are an object of our parent. We call it a parent class or the superclass or the base class. I don't know why there's so many different ways of saying it. So you have a base class and a derived class. You have a parent class and a child class. You have a superclass and a subclass. Right? 3 different ways of saying which class you're inheriting from. Okay? And then what override does is say, hey, don't do the thing my parent class does. Don't do the thing my superclass does. Don't do the thing my base class does. Do my thing. So instead, we're going to return, let's do our name plus has, I don't know, let's plus number of sides plus number, I don't know, sides and a perimeter of plus get perimeter. Okay, let's return a string. Maybe we'll say this is our name, it has this many sides, and it has a perimeter of, sure, we could do that. All right, we haven't done any string formatting yet, have we? That's a shame. There's a nicer way to do this than all these ugly plus things, but I don't think we've talked about that yet. All right, nope, I can't run that one. I have to run inheritance. That's right. Now when we print it, we get the version that we wrote that overrides the parent class behavior, which is super cool. There you go. Octagon has 8 sides and a perimeter of 40. 5 times 8, right? Because if we were size 5 each time, 5 times 8 is 40. That checks out. We're feeling good so far. Okay. So we wrote our class. Now we've said, hey, I don't want the version that my superclass does. Surround with. What do I want to surround with? No, I don't want that. That's fine. Okay. And then you get this little green dot here to tell you it overrides, which is cool. Okay. So this override, this is an annotation here in Java. It's not necessarily part of code. It's telling the compiler something special. So you don't actually need that add override to have a toString method. It is not required, but what it does for you is, oops, sorry, undo, not paste, is the compiler will then check to make sure this actually does override something. Because a lot of times what people do is they'll put like toString here by mistake, which is fine. You can have a method named anything you want, but now it flags and it says, oh, you meant to override, but you didn't. Remember to have another method with the same name, right? It needs to match letter for letter, case for case. So this is not overriding because it's a different name. So .toString is different than .toString. So then I would have to say octagon dot capital T toString versus lowercase t toString. I'll see one comes from Polygon and one comes from object. If this one comes from object, this one comes from Polygon. They're not, there's no overriding there. Okay, so this annotation is super helpful because then the compiler will check to make sure you did it right here. And then when I say dot toString, I just see the Polygon version. Super cool. Okay. So polygons are objects, right? Any class we write are objects. It is a relationship there with object. And there's actually a keyword for that. We say extends. Hydration. Thank you so much, Demovsky. Yeah, I got a little coffee left. We're about to take a break. I'll go fill up my mug, hydrate some more. So extends is the keyword here. We say here's my class that extends another class. We'll say object. Object. I object. Probably the wrong object. Object. Okay, so this is unnecessary because it already happens. But this is what we're actually doing. We're extending object. Because we're saying, hey, I am a object. Object is my parent class. Object is my base class. Object is my super class. Now, I prefer super because there's a keyword we're going to learn after we come back from break that will do things of your super class. Will interact with your super class. And the keyword is super. So I like calling it your super class, but it's also your base class. It's also your parent class. You got all sorts of ways of calling it here. But again, we don't actually need to tell Java this because this happens automatically. Okay? So we'll say it automatically extends object, which is cool. Okay? All right. So I got almost 11 o'clock. Why don't we take a break? We'll come back in 10 minutes and we'll look at doing more inheritance, which is lots of fun. Okay? We'll look at, can we extend Polygon to make something that is a polygon, but it's a specialized version of Polygon with new behavior. Okay? All right. So let me throw some music on and we'll take 10. We'll go get some coffee. Make sure you get lots of coffee here. It's still early in the morning and we'll go from there. All right, so let's go to break for 10 minutes. Let's see, that'll put us at 11:06 a.m. Eastern Time. And hit play on the music, and we should be good to go. See you folks in a couple of minutes. Hey folks, welcome on back. Alright, no, sorry, I have to post quiz 7 still, so I will do that after I'm done with class today. Sorry, I meant to post that on Wednesday and then left myself a note and forgot about it. So my apologies. I'll leave that open a little while for you folks. So, alright, so we've done Polygon, right? And we have overridden toString. Now what we get to do, right, the idea here, right, with object-oriented programming and writing classes is that our classes are amazing and wonderful and everyone is going to want to use them. And, right, we could just take Polygon and use it in tons of different applications. That's kind of the pie in the sky goal, right? That we get to reuse these objects, these classes that we write, okay? So what we don't want to do then is go change Polygon very often, because that means we have to change everywhere that uses it. It's kind of a downside as well, because then it makes it harder to change things. But what we get to do instead, if we say, well, you know, I really like all the things Polygon does, but what I really, really, really want is, say, a rectangle. I want it to always be a rectangle. We don't want to make Polygon always a rectangle, because we're using it for octagons, we're using it for hexagons, we're using it for pentagons, we're using it for, I don't even know other math names. Sure. Oh, what's the other one? Parallelograms and trapezoids. Okay, there's a lot of them. Right, so if we want all the things that Polygon does, we want it to be a rectangle, what we can do is we can inherit from it. We can extend the class and make a specialized version of it. So what inheritance does is it lets us create a specialized version. So we'll say, hey, I'm a rectangle, I extends Polygon. So rectangle now is a polygon. It does all the things Polygon does. Right off the bat, we get all the things Polygon does. But now it's mad at me here because Polygon has a constructor. So if our parent class has a constructor, we have to call the constructor. That's why it's yelling at me. Because Polygon has one, we have to call it. So sure. So let's make public rectangle. And now rectangle, we know how many sides a rectangle has. Right? So, but maybe rectangle will say, give me an int, a length, and an int for width. No, you know what? Forget that. We won't. Let's not even bother. Okay? So we'll have a constructor. We don't need any arguments because I know a rectangle has 4 sides. So what we can do is we can tell our superclass that it has 4 sides. Oh, it probably needs a string for name. How about that? String for name. So we can pass it a name, right? Because Polygon's constructor. So super says call my constructor. Call the superclass constructor. Give it a name and give it 4 sides because I'm a rectangle. So we'll ask for the name, we'll just pass it right to Polygon, and then we'll tell it it has 4 sides. So super is the keyword. Calls the superclass constructor. Okay? All the other things, sure, we will do the things Polygon does. So if we come back to inheritance and we make a rectangle, rectangle equals a new rectangle. I don't know, we'll call this one small rectangle, and it's all we need to give rectangle, right? Just the name. So now I look at rectangle, and I have some methods. Now notice none of them are bold, because none of them belong to rectangle, but like get number of sides and get perimeter, those belong to Polygon. Get side length belongs to Polygon. Now, a set side length is probably inappropriate here, right? Because if I'm a rectangle, my lengths can't be different. So we have to be careful here. So what we want to do is we want to change the behavior of rectangle, or of Polygon. So we're going to override. We're going to say, hey, instead of doing the thing my parent class does, oh, hat, thank you so much. Let's flip back to the Mickey hat. Is that one okay? Is that all right, Fallen? Or I also have the chest bra hat I could do if you're interested. Or I've got the sun doily hat as well. We got choices. So we're going to say, hey, I want to override my parent class behavior, my superclass behavior. I want to change public void set side length. That takes an int side index and an int side length. Okay, we want to change that behavior. What we're going to do, we want to say if my side length, side index, there we go, side index is equal to 0, or my side index is equal to 2, right? So what we're going to take the opposite side, so side 0, side 2, or side 1 and side 3. If it's 0 or 2, I need to set the side length of both of them. Now, I can't just say set side length. right? And I don't have access. So this idea here in Polygon that this is a private array list, I can't get at side lengths. So anything that is private is inaccessible outside of Polygon. So what we could do is we could call the method. But if I call set side length, it's going to call my method. So I need to call my superclass dot set side length. No, not that one. Not that one. My goodness, stop. Set side length for 0 and the side length, and for 2 and the side length. So my specialized version will run when you call set side length. If you told me side index 0 or 2, I will ask my superclass to set both of them 0 and 2, because I need to set them together, right? When you change the side length of a rectangle, length needs to be the same on both sides, and width needs to be the same on both sides. Okay? And then else if my side index is equal to 1 or side index is equal to 3, let's do the other ones, right? So if you want the widths, let's do the widths for 1 and 3. Okay? So I'm going to change the behavior so you can't use the Polygon version here. You need to use my version here, which makes sure that my class maintains its integrity. Right? You should not be able to put a rectangle into a bad state where it's not actually a rectangle anymore. The class's job is to make sure it stays in a good state. Okay? So that's how you set side length. Now, we've changed some behavior. Now, what makes us special? Right? We know we have 4 sides, but if we know we're a rectangle, we can also now get area. Right? And we're going to return, I need get side length of 0 times get side length of 1. Right? That's my area. Length times width. Okay? Now I can get the area out. So now I do all the things Polygon does, but I'm a specialized version. So inheritance lets me not have to copy paste a bunch of code to do all the things Polygon does. Right? I don't have to redo any work. But it lets me specialize it. Say, oh, I like all the things it does, but I want to be special. Right? I want to add either change some behavior or add functionality. A specialized version. And that way I don't have to change Polygon, because maybe I'm already using Polygon for other applications. So inheritance is super useful. It's one of the fundamentals of object-oriented programming that we can inherit from existing classes. Okay? Now the other cool thing you can do, if you want your child classes or subclasses, like super and sub, if you want your subclasses to have access to your attributes, there's a new access modifier here. So instead of being public, right, we don't want to make our attributes public because then everyone has access to them. That's bad form. We can say they are protected. Protected means I have access and my subclasses have access to them. So now over in Rectangle, if I wanted, I could go right to side lengths. I'd have access to side lengths here. And I could call all my own sets if I wanted. Again, it's totally just a design decision. If you want your subclasses to have access, you make it protected. If you don't, if you want them to go through your methods, you make it private. Totally up to you, and depending on how you want to write your classes. Okay? We've got rectangle. You can set side lengths, and you can get an area. So maybe if we also have an area, maybe we want to change the parent class behavior for my toString. Let's change public string toString. Let's say I want to do all the things my parent class does, but I also want to give my area. So what I can do is I'm going to say return, I want super.toString, do the superclass version, and then add with an area of, and we'll add in get area. Super says go to the superclass, do the superclass version. So super dot will call methods, super parentheses will call the constructor. So it's just saying go to your parent class, go to the thing that you extend. So it will do the Polygon toString, and then it will add my additional special version here. So if we make a rectangle, we'll set the side length of 0, we'll set that maybe to 5, and then we'll rectangle dot set side length of say, set side length. No, not that set. Set side length. I don't know why the tab is terrible sometimes. 10. We'll make it a 5 by 10 rectangle, and then we'll print out a rectangle. Rectangle. This is a small rectangle. Rectangle. Okay, give that a run. We should get a perimeter, right, of 30 with an area of 50, if we did it right. Perimeter of 30, area of 50. Small rectangle has 4 sides. Cool. Oh, nothing better than fresh coffee. All right. So we did polygon, we did rectangle. Now, what if we want a special version of rectangle? What if we want to make a specialized version? Sure, you can have as many levels of inheritance as you want to. You can go nuts, which, you know, is possible to have gone too far. Oh dear. Oh dear. And little guy apparently is throwing up. Aw. Might have been drinking too much shower water. Let's see. Poor guy. Okay, so let's do one more version here. Let's inherit from rectangle. We'll put maybe a square, because a square is a rectangle, but it's a special version of rectangle. Okay, so square extends rectangle. Okay, right off the bat, it's complaining because rectangle has a constructor. I don't have a constructor yet, so I need to call its constructor. So if rectangle had a no argument constructor, right, I remember a constructor that doesn't take any arguments, it's not going to complain. So I don't actually want this here, but I'm going to show you real quick. So if we write rectangle here, and we just call super with like nothing and 4 sides, so if we say we have no name and 4 sides, now square is going to stop complaining right away. And it's going to stop complaining here. There it goes. Because if there's a no argument constructor, it will actually automatically get called. That's what happens with object, right? We extend object. We never call the object constructor, right? But it by default used a no argument constructor. So if you have one in the parent class, you don't have to call it explicitly in the child class or the subclass. Okay? But I want a constructor to have name here. So we'll do the same thing. So we'll write public square takes a string for name, and it calls the superclass constructor given the name, right, which is the rectangle constructor. Sure. Now, square is a rectangle. It does all the things rectangle does, but we need to change the behavior of set side length. Public void set side length. Right, given an int for side index and an int for side length. Right, if you call set side length, if I'm a square, I need to do all 4 every time. So I'm just going to say super.set side length of 0 is the side length. And then I'm going to call super set 1 of side length. Because I know that rectangle, if I give it 0, does 0 and 2. And I know if I give it 1, does 1 and 3. Right? I could also call 2 and 3, but that's kind of redundant here. There's not really a point. So if you set any side length, I'll set all of them to 0 and 1. Right? Which sets length and width of my parent class. Okay, that's the only thing I need that's special. Right? Besides that, I can still get an area, I can still get a perimeter, I can still get the number of sides, I can still get side lengths, I can do all the other things my classes do here, but now I'm a square. So let's make a square. Big square equals a new square. We'll say it's a big square. And then big square dot set side length. It doesn't matter which one we give it. Let's set this one to like 50 here, and then we'll print out. Oops. There we go. Our square, big square. Okay, so 50 times 50. So our perimeter should be 200, and our area should be 2,500. Is that right? Sounds about right. Let's see. Perimeter is 200, area is 2,500. Okay, so you can make as many subclasses as you want. Right? We could also, if we wanted, make a different kind of polygon. We don't have to go this rectangle route. We could make a parallelogram that extends polygon, right? Or we could make a hexagon that extends polygon, that forces the number of sides, or anything we want to do, right? Anything that is a polygon, we can make a specialized class for. It doesn't have to come from rectangle. It doesn't have to come from square, right? And you can have multiple types of children of it here, right? Or multiple child classes or subclasses here. Right? Anything that is a polygon but it wants specialized behavior, we can do. Okay, how you feeling so far? Feeling good? So it's going to take some practice. We're going to have to do it, and we'll be using inheritance again when we get to our GUI applications, graphical user interface. Because all of that happens through inheritance, through the magic of inheritance. Okay? So I think that's a good point. We still have Thursday to talk about inheritance. We can do some more work on it Thursday. Why don't we break a little bit early, give you some time to start on the Big Int project, since several of you were kind enough to admit you hadn't started yet. So start on it, and then go to study group at noon. Right? Starting at 12 to 1, get together with your classmates and our amazing SI and start working on the project. Right? Discuss some ideas or practice any of these things. Right? That's your time to talk more about the stuff we're learning in class as well. Not just project work time, but hey, do you want to talk more about inheritance? Do some practice with inheritance, that sort of thing. Okay? So we'll call it a day. We've got more we can talk about on Wednesday, and we'll go from there. How's that sound? Let me go ahead and make sure all my code's out on github.com for you. Close down NetBeans. Fire this up. Let me clear off my whiteboard. Come on. 1500. Come on. 1500. My goodness. Come on. There we go. All right. This is inheritance. All right. We should see what else is out in Twitch land. Go pester. Raid somebody for fun. Go learn some other good things. Inheritance, push, will be out there. Yeah, it's going super slow. Oh, man. I think OBS just eats all my resources. Not even too bad. Like 15% CPU shouldn't be too bad. Shouldn't make things just lock up. I don't know what the deal is. Let's see. Oh, got a lot of people streaming now. That's fun. Yeah, have a great day. Thanks so much. Let's, oh man, just nothing is loading. Wow. Let's go this route. Let's head over and learn some chess with my friend Levy. He's fantastic. If I can get it to even click. Come on, click. Click the button. Click start. There we go. All right, it's working on it. It's counting down. It's just so slow. Sorry about that, folks. All right, if you've got questions, let me know. I can meet after I get back from doing my shot today. I'll probably be back about 2:30 or so, and we can go from there. Oh, come on, load, friends, load. Nothing. Nothing's loading. Maybe it doesn't like having that open. Maybe that'll be better. Oh, someone went wrong? Let's see. It's trying. It's trying. Happy Monday. Get yourself some coffee. You take care. See you around.
Is that when you guys do silly things,